Hello everyone, my name is Rafael F. Bomosu Trainer. I am a cybersecurity student at the Grand Canyon University. Today is a presentation for CYB-610 and today I'm going to be using Nmap to conduct several vulnerability scan and analysis on my Kioptrix 1 VM from my Kali Linux box to examine vulnerability within the system, and this presentation will show you how intruders can exploit these vulnerabilities to gain root access to your system. So let's get started. In this lab, Kioptrix 1 was examined through various methodologies to identify the vulnerabilities linked to targeted systems. I conducted a scan of my Kioptrix 1 using my Kali Linux box for the following port detection, service and version detection, OS detection, and I also did an intrusive scan. On my first screenshot on the left, I did an Nmap scan on all network devices within the 192.168.56.04/24 subnet. And when I did that, I was able to identify my Kioptrix 1 VM IP address, which is 192.168.56.103. I was also able to identify a couple of open ports. I saw that port 22, port 80, port 111, port 443, port 139, SSH, HTTPS, they were all open. And my screenshot on the right, it shows that I did an Nmap scan to determine the OS version of my Kioptrix, and I found out using my command, which is nmap-0, using my Kioptrix VM IP address, which is 192.168.56.103, and I was able to determine that I'm running a Linux 2.4.x, and you can see down here is 2.4.9, 2.4.18. So this I was able to use to determine what operating system and what version operating system my Kioptrix VM is using. For my second screenshot on the left, you will see that I did an Nmap scan for open ports and to identify the version of services, and I used the command nmap-sv using my Kioptrix 1 VM IP address, which is 192.168.56.103. I was also able to determine there are several ports that are open, port 22, port 80, they are all open. And when you look on the right, I was able to do an Nmap intrusive scan to determine several vulnerabilities. And these were the vulnerabilities that I found with my system after I ran my intrusive scan to determine these vulnerabilities. You can see there are several vulnerabilities I was able to determine after running my intrusive scan using the command nmap-p-a-a and putting in my Kioptrix VM IP address is 192.168.56.103. So on this screenshot, I was able to do an Nmap scan for network enumeration. And what normally you use Nmap scan for network enumeration is that you want to determine the network range. You want to identify active machine and users. You want to find open ports and services. You want to find operating system fingerprinting. You want to conduct vulnerability assessment and mapping the network resources. So that's what network enumeration is. So anytime you enumerate your network, is that you're trying to determine your network range, trying to identify active machine users, and you're also trying to find open ports and services. As per the instruction, we were asked to provide to run three additional scans. And once we ran those scans, we needed to show the output in a screenshot. So this is scan number 1. So I ran a put version scan or a service version scan on port 80. So this is the command I used. So I ran this command on port 80 to determine what service version port 80 was using. So port 80 is designated for HTTPS. It's associated with the web. It is utilized to identify vulnerabilities and other irregularities related to that particular port. So I ran that service version scan on port 80. So the second nmap command that I ran on my Kioptrix VM, this was a sync scan, and this sync scan is designed to invade detection firewall and intrusion detection systems. It enables the user to interact with a system without fully executing a three-part handshake. So I ran the command. This is the command right here. This is my Kioptrix VM IP address, and this is the output I got. But like I was saying, as it relates to the three-part executing a three-part handshake. So what the three-part handshake is the sync ACK, and it's ACK. So sync is for synchronization. Sync ACK is for synchronize acknowledge, and ACK is acknowledgement. So what that does is that the standard TCP connection established process, also known as the sync, like I said, the sync ACK and ACK handshake, where clients initiate a communication by sending a sync packet. The server will respond the sync ACK packet, and the client then sends an ACK packet to complete the connection. So the client will send a sync, and once the client sends a sync, the server will respond with acknowledging that the packet was received, and the client sends an acknowledgement packet back to the server confirming receipt of the sync acknowledgement and completing the connection setup. So that's what it meant by the three-part handshake. So this is my third additional nmap scan that I ran. As it is a non-port scan utilized to examine devices on the network. Although it may appear less advantageous than a port scan, the ramification of identifying every device on a network including security system and doorbell camera, are significantly intrusive. So what we do with this scan is that you want to determine all the devices on the network. So if you have a server, if you have a desk phone, if you have a camera, if you have 10 different computers, you have whatever devices you have on the network, you want to run this scan to determine what devices are connected to the network. You could do this to your home network, you could do this to the office network, but you just use this to determine what devices are connected to the network. And this is the command that you use, and I ran this on my Kioptrix VM, and this is the output. I ran this on my Kioptrix VM, and this is the output that I got. Flaw hypothesis methodology. A list of possible defects in a software system is produced through the analysis of the requirements and documentation in the flaw hypothesis methodology, a systems analysis and penetration forecasting technique. The enumeration of possible vulnerabilities is subsequently prioritized based on their probability of existence and the ease with which they could be exploited to obtain control or compromise data. The system's actual evaluation is directed by the priority list. The hypothesis of my discovery is that this system contains multiple vulnerabilities, with the most easily exploitable being port 22 and port 139, which corresponds to secure shell and server message block respectively. So my hypothesis, I determined that port 22 and port 139, they're easily exploitable. After I did all of my thing, that was why I found out that both port 22 and port 139, they can be easily exploitable, meaning hackers can easily exploit these ports, both of these ports. So as I mentioned in my previous slide, that both port 22, which is SSH, and port 139, which is Samba, they were easily exploitable. So in my investigation, I found out that OpenSSH 2.9 P2, I discovered that this version was susceptible to an off by one error in the channel code. This code enables malicious actors to obtain privileges within the system, and a further vulnerability linked to this flaw is information disclosure. The vulnerability permits a remote attacker to enumerate all accounts within the system. So I also found out flaw 2, which is Samba, which is port 139. Upon investigating Samba version 2.2.1a, it is evident that there are at least two techniques available for its exploitation. The initial method utilized Metasploit, while the subsequent version employs a pair script. The initial approach involved employing hacking tools to obtain root access to the system. The second method enables remote authenticated user to introduce a denial of service application crash and potentially execute arbitrary code through a Samba request containing an excessive number of security descriptors, resulting in a heap-based buffer overflow. So those are the two flaws I found with port 22, which is SSH, and port 139, which is Samba. Thank you for watching my video presentation.